Cruising through 2.1, here we are, 2.1c, and this is example 9 on bottom of page 113. If you remember from a couple videos back, I had mentioned that when we get four terms together, one of the first things you're going to look at is, can I group? So really kind of like whenever you get an even number of terms, see if you can group these. So what I'm going to do is I'm going to put a parenthesis there and a parenthesis there and see if I can pull some stuff out of here. So right here, I'm going to pull out an x squared because that's the smallest variable, and that leaves me with x plus 2. And then I'm going to pull out a 9, and that's going to leave me with an x. And this is another one of those places where you have to be really careful. Remember when I said it has to be the same as what you have over here. A lot of students will look at this and say, I am pulling out a 9, so that means I'm going to have x minus 2. But one of the things you have to look at is this was a minus, before I put the parentheses here, this was a minus 9x minus 18, right? Well, when I put a parenthesis around here, that automatically means that this is going to be distributed on both the 9x and the 18. And the problem is when I distribute that negative, it's going to make this a positive 18, and that's not what we had in our original problem. So in order to make it back to our negative 18 right here, we have to be able to multiply this negative 9 times this 2 and get a negative 18. The only way we can do that is to change that to a positive 2. So even though it may be confusing, remember that when you put parentheses on, and if you were to distribute this back into here, you have to get your original. If you don't, you're going to have to change this sign. And another cue is this sign here is a plus, so this one has to be a plus. So I could rant and rave about all of the theory behind all of that, but it's just some things to just remember rather than going through all of the y's. So now I've got an x squared minus 9 and an x plus 2, and we continue on. Now, if you remember from a while back, when we have an x squared minus 9, that is the difference between two squares. So if you remember, just that one parenthesis can be broken down into two more. Square root of both terms with a plus sign and a minus sign. And then we have a x plus 2. So how many answers do you think we're going to get from this problem? 3. We have 3 factors. And so the x minus 3 equals 0. The x plus 3 equals 0, and the x plus 2 equals 0. So solve for x. Once you're at this point, you can pretty much look and see what your x is going to be. It's going to be the number here, the constant, with the opposite sign. So x equals 3, negative 3, or negative 2. So you can just write that as your answer. Rather than write it out, x equals 3, x equals negative 3, x equals negative 2. You can just write it simpler like that. All right, so let's go on and do a couple more that are a little tricky in the book. So I'm example 10. This is identities and equations with no solution. Now remember when we were doing linear equations, and we had two different numbers that we would get for an answer, and or two different equations, and when you graph it, they gave you that. You could get a parallel line. Basically, the parallel line meant there were no solutions to the problem. So what we're going to do here is we are going to look at an equation such as 2 times 3x minus 4 equals 3 plus 6x. So let's go ahead and solve this for x. Three plus 6x. And then we're going to continue along here. So in order to get the x's together, I'm going to subtract 6x from both sides. And if you notice what happens, those go away. But when we do this, those go away as well. And we get negative 8 equals 3. That is a false statement, which means when we look at our original equation, there is not an x value in the whole history of the universe that we can put in here to make this into a true statement. There aren't any. So when your x's disappear, when they cancel out like this, and you're left with just two constants that are equal to each other, and if that's a false statement, there is no answer. Another special circumstance that we run into. So here we go, negative 15 plus 3x equals 3 times x minus 5, example 11. So let's go ahead and just do our distributing. Okay, I'm going to bring this over to the left side, so I'm going to subtract 3x from both sides. Those go away, but look, this goes away also, leaving us with negative 15 equals negative 15. Our x's disappeared, but instead of getting a false statement, like we did in our last problem right here, when we got a false statement, in this case, we get a true statement. Whenever we get a true statement, even if our x's disappear, if we get a true statement like this, that means any number in the whole history of the universe will work for this. So the solution set is the set of real numbers. The set of real numbers. So anything works for that. So that is 2.1, and we are done after only 3 videos finally, and you can get moving on that.